Hello students, welcome to Competitive Exam Library. Today we are going to see how a rotating magnetic field is produced so we are going to see rotating magnetic field, how it is produced. Okay, rotating magnetic field production in induction motors. Today we are going to see this topic. Okay, how we are going to produce a rotating magnetic field. So when a three-phase winding, okay, when a three-phase, so we already know that when a three-phase winding given, okay, three-phase windings displaced in 120 degrees, okay, displaced in 120 degrees are fed by, okay, are fed by three-phase currents, displaced in time, okay, displaced in time by 120. They produce, okay, they produce a rotating magnetic field. They produce a rotating magnetic field. This is the concept here. Okay, that's why I am writing rotating magnetic field, which is rotating in space, which is rotating in space, which is rotating in space. So here see this this winding, this diagram. If you observe, whenever you are giving a three-phase supply for the various stator windings, so this is the stator, okay, stator windings. So there is a air gap will be there. So we are already shown that how the rotating, how the stator and rotor. So if you consider this as the stator, so the rotor will be, there is some air gap will be there between stator and rotor. So this is the rotor if you consider, okay, this is the rotor, and if you see this is the stator. So this is stator. So there is some air gap will be there whenever you give a three-phase supply for this stator. So there will be a rotating magnetic field will be produced in this air gap. So here is the air gap between the stator and rotor. This is the air gap. So between this stator and rotor, there is a rotating magnetic field is rotating in this space will be produced. So let us imagine some values here. Okay, let us consider phi max is the maximum value of the flux. Okay, maximum value of flux due to any phase, we are considering. Next, phi r is the resultant flux, phi r is the resultant flux at any instant, is the summation of, okay, at any instant it is summation, okay, it is summation of three phases, okay, summation of three phases we are considering, okay, that is we are considering three phases as phi 1, phi 2 and phi 3 like that. Okay, three phases summation we are considering, that is the resultant flux due to three phases. Okay, due to three phases we are having the three different fluxes, phi 1, phi 2 and phi 3. So because of this, so by considering all these values, we are going to analyze how the rotating magnetic field will be produced. Next, see this diagram. See here, this is a very important diagram. If you observe here, so if you observe, this is the one phase we are considered. Okay, this is the one phase. Okay, next this is the second phase we are considered with the dotted lines. Okay, so this is the another phase, that is another phase that is with the three phases. So here I have considered some time instance, okay, so which is 1, 2, I think so you are able to see 2, 3 and 4. At this instance, if you observe the each phases, it will have different instantaneous values. That is, the phase 1 is having different value, phase 2 is having the different value, phase 3 is having a different value. See, at this 0 instant, let us see at this 0 instant what is happening here. So you see the values of the different phases. this at this 0 instant, if you observe, the value of this is the phi 2 value, okay, and this is the phi 1 value, and this is the phi 3 value. So at this instant, that is the 0 position only, we have 3 values, that is phi 1 is becoming 0, phi 2 is of a negative value, phi 3 is of a positive value. So for that, what we will take? We will take the values as phi 1 I am considering, that is at 0 instant, at 0 instant theta is equals to 0. At theta is equal to 0, you can observe this is taken at theta only. So phi 1 is 0. What about phi 2 value? Phi 2 value is becoming a negative value, that is minus root 3 by 2 phi m. Next, phi 3 value you observe here, that is becoming a positive root 3 by 2 phi. So here at this instant 0, it is having some different values of maximum flux. So if you add these fluxes, if you add this, so phi 2 will be here, if you observe, phi 2 is exactly opposite to phi 3, okay, because it is exactly magnitude wise it is equal, and but they are having a negative sign, so that's why we can consider it as both are opposite. So if you observe the phasor diagram here, if you draw the phasor diagram, you see here, there the phasor diagram has drawn here. So this is, let us draw phi 1 here like this. Next, if you draw the phi 2, what about the phi 2 value? If you draw phi 2 will be like this, phi 3, sorry, because phi 1 will become 0. So phi 2 and phi 3, they are exactly opposite. One is going in this direction, means one is going in the opposite direction. So the resultant will be like this. The resultant will be, you are going to get the summation of these two vectors, you are going to get, that will be a resultant flux will be here. So this in this direction, that means the flux is the resultant, this is the resultant flux. The resultant flux is in the downwards direction. So what we can write, the resultant flux, so the vectorial addition, you already know how to do the vectorial addition, 2 times of root 3 by 2 phi m. You see, otherwise what you can do, you take this triangle like this, you draw a perpendicular, so make the triangle, so you do this, this will become 30 degrees. So you make a triangle like this, then you can calculate the total resultant. So whatever thing, so if you take this is the half, okay, so this is the resultant flux will be phi r by 2, okay. So here you are going to get what is this? This is the phi 2, this is the phi 2, so this is phi r by 2. So exactly if you calculate, if you take cos 30, then you are going to get so let us take that also, in that fashion also will do, and in normally what we will do is cos 60 by 2. So here what is happening, 2 will gets cancelled, and root 3 times cos 30, what is the root 3 cos 30 value, that is cos 30 is once again root 3 by 2, that means it will become 3 by 2, that means 1 by 5 times of phi m. I forgot here phi m, okay, here also you are going to get the phi m, here also phi m, 3 by 2 phi m here. So what you are going to get, 1.5 times of the phi maximum you are going to get here, that is the resultant flux. How you are getting, so if you take phi r by 2, okay, so phi r by 2 what will becomes, so you see here from that triangle, if you see this from the triangle, you can take it as cos 30 is equals to, what we can write, cos 30 is equals to phi r by 2 divided by phi 2, we can write. So you already know phi 2 value, that is phi r by 2 is equals to, phi 2 is how much, root 3 by 2 phi m into cos 30. So phi r will become 2 times of root 3 by 2 into phi m cos 30. Then you are going to get your answer as 1.5 times of phi maximum value. So in that fashion also you can do. Let us see another instant. Okay, if you see the another instant, let us consider the another instant, what is happening in the case of this. At the instant 1, if you observe, there is which value is becoming 0, that pi 3 value is becoming 0, and at this instant there is some phi 1 value, that is phi 1 value will be there, and phi 2 value is becoming negative value. It is a negative value and it is of some positive value and it is 0. So at the instant, what is happening at instant theta is equals to some 60 degrees I am considering. At theta is equal to 60 degrees, what is happening? Phi 1 is of a positive value, that is root 3 by 2 phi m. Next, phi 2 will become 0 value. Next, phi 3 is of a negative value, minus root 3 by 2 phi m, minus root 3 by 2 phi. So here this phi 3 is becoming 0, this is the phi 2. Okay, phi 2 value is becoming minus phi 2 minus root 3 by 2 phi. So at this instant, what is happening? If you draw the resultant vector diagram, you see this is the phi 1, and if you draw the another phi 2 diagram, you see this is the phi 2 diagram. Okay, the both resultant will be added, the resultant will be added here, so that you are going to get the resultant will be in this fashion. The resultant will be like this. So here phi 1 is of a positive value, phi 2 is of a negative value, phi 3 will become 0. So once again, if you do the same calculation by considering, what you have to do, you take some angle like this, you take some, this is the 30 degrees, then you calculate, this will become phi r by 2. Then at every instant, if we calculate, and if you observe the direction, previously it was downwards, it is going, now it was rotated, somewhere it is rotated, the resultant will be in clockwise direction. Next, if you observe at instant 3, at instant 2, if you observe at instant 2, what is happening here? So at instant 2, so phi 2 value is becoming 0, and this phi 3 value is becoming a negative, and since the phi 1 value is of a positive value, because of that, then what you will get? Because of that only you are going to get phi 1 and phi 3. Phi 3 is of a negative value, exactly 1 degree. Once again, the resultant vector is rotated in this direction. Once again, the resultant vector is rotated in this direction. At the instant 180 degrees, let us consider at instant third position, 180 degrees. So 180 degrees, what is happening? Phi 2 is of a positive value, phi 3 is of a negative value, but what about phi 1? Phi 1 is becoming 0, that's why I am going to get 2 and 3 here. The resultant will be rotated in this direction. Like this, if you consider at different instants, I have shown the diagram here. This is at instant 1 and instant 2 and instant 3, instant 4, instant 5, instant 6 and instant 7. So if you consider all these instant at different instant, the resultant vector will be rotating. So as the resultant flux is rotating, you can say the resultant magnetic field also rotating. Okay, so the resultant magnetic field also rotated. You can note down the different points from this concept. What is the thing is the resultant flux. Okay, the resultant flux will be rotating. The resultant flux is having magnitude of what is the magnitude it is getting? Every instant you are going to get, that is 3 by 2 times of phi m, 3 by 2 times of phi m, that is 1.5 times of the maximum value, 1.5 times of maximum value due to any phase. Next, so what is another point you can note down is the resultant flux is rotating. That is what we have seen. The resultant flux is rotating. The resultant flux is rotating around the stator, at synchronous speed, given by ns is equals to, okay, given by ns is equals to 120 f by p. So because this is rotating at synchronous speed at 120 f by p. So as the rotating resultant flux is rotating, that is resultant flux is rotating, the resultant field also rotates. That is what the resultant field also will be rotating in air gap, in the air gap between the stator and rotor. This is the concept of how a rotating magnetic field is produced in the air gap between the stator and rotor here. Okay, So that is the concept how a rotating magnetic field is produced in the induction motor. So there is we are already seen. So there is a definitely the speed gap will be there, that is a speed difference will be there. So that is called the slip. Slip is defined as the slipped speed. We will call it as this ns minus n as slip speed to the ratio of synchronous speed. Okay, this is called as the synchronous speed. This is called as the slip of the induction motor. So whenever you have slip will be there only, then will be EMF will be induced. Slip can be represented in percentages also. If you multiply with 100%, then you are going to get in percentages also. Sometimes you will get in the problem. So what is the slip? Slip will be, so S normally it will represent as ns is equals to n divided by ns, where the terms what we are used here, that is ns is the synchronous speed, that is you are already know ns is the synchronous speed, ns is equals to formula also you already know 120 f by p. Next n is the rotor speed. Okay, n is the rotor speed. Next s is the slip here. If you want to find the rotor speed in the problems, what you have to do, see this equation, we can write ns minus n divided by ns into, so I can multiply ns into s, that is equals to ns minus n. So I can take n as, that is ns, you can take it as common, s minus 1, that is ns is equals to, so what we can write, sorry here there is a mistake will be there, here you can see. So I will bring this n to this side, n is equals to ns minus ns into s we can write. So what we can write, n is equals to ns into 1 minus s we can do. So that is the, what is the rotor speed. The rotor speed formula will be very important. So what are the formulas to be, you have to note down, I will highlight here. First thing is slip, first thing is the synchronous speed, next thing is the slip, next thing is the slip formula, next the rotor speed. These are the questions they are going to ask in the external exam. That's all in this video. In the next video we will see constructional details of the induction motor. If you are seeing first time this channel, please like, share and subscribe the channel. If you have any queries, please make comment, I can reply. Thank you very much.